Talk 1.3, transformations and congruent figures. Okay, a transformation is a change in the location or a size of a figure. Today we're not going to talk about the size changing, we're going to talk about the location change. Okay, so we're going to focus on location today. With transformation, there are three types of transformations that can happen with location change. One is translation, one is reflection, and one is rotation. Translation, to me, is the easiest one to detect or to see. It's when something like slides, okay? You remember, I don't know if you guys ever did this, but when you were like kids, did you ever see those like little puzzles that are missing like one little square and you have to slide them to make the picture or whatever? Okay, those are translations that are happening, okay? We're translating things by sliding it. Just like in basketball when you play defense, okay? You're technically doing a translation when you slide to stay with your player, okay, on defense. So there's some visuals that help you out maybe a little bit there. Okay, so that's a translation. So this here, if you notice, the right angle is there. All it did was slide across. It slipped, okay? Nothing else happened. A reflection is easy to remember too because you see your beautiful self in the mirror every day, so you see your reflection, right? Reflection flips it. A lot of times we reflect over the X or Y axes. We'll reflect over certain points too. But if you notice here on a reflection, my right angle is here. I did right triangle so you can visually see it better. And down here, my right angle is there. So the right angle on a translation stays in the same position. But on a reflection, it changes where the position is. Okay, just like if you take a selfie, when you take a selfie, it's flips, your image is flipped technically. Okay, if you ever noticed that, you're like, why is my, I don't know, for girls, if you have like something in your hair, why is the flower on the other side instead of this side?
Happens all the time.
I knew it, Bryce, I knew it. So it's like a reflection. That's what that is. The last one is a rotation. And personally for me, this is my hardest one to grasp in my mind. And I don't know why. I don't see it as well. So a rotation is when something is rotating. When we do a rotation 90 degrees, 45 degrees, 180, 360, those are easy to see. But when we do a rotation at 22 and a half degrees, it's a little harder for us to visualize. So rotation means that I'm physically rotating something, and usually you rotate something about a point. So it might be a point on that triangle or object, or it might be I rotated about the point of the origin, about 0, 0, which means it would be like pretending that there's a string here and you're rotating this image around that string with that string. Okay? So yeah, that's rotation. Okay? You have two other vocab words that are in this section, corresponding side or corresponding angle. And they basically have the same definition, that it's where it has the same place in two figures. So if something is corresponding, if I have a corresponding side, it means in this figure and in this figure, they're the same. If I have corresponding angles, that means in figure A and figure B, the angles are the same measure. Okay? Does that make sense?
Yes.
Okay. Thank you, Bria.
You're welcome.
And then the other thing I have written right here, this blue that says rigid formation, is when something is a transformation, like a translation, a reflection, a rotation, it is also considered a rigid formation. So those two words, transformation and rigid formation, are going to be interchangeable. So in your textbook, when you see something say, tell me the rigid formation, we're looking for this. Tell me the transformation, we're looking for this. Okay? They're interchangeable words. They're the same thing. So those are the three we're going to focus on today. We're going to take a look at my board over there that I have stuff written on, talk about it a little, take a look at a couple problems in your book, and then we're going to go online. Hopefully it will work because it did in my other class. And I'm going to show you a little tool that your book comes with that can help you visualize it on your homework. Okay? So, first things first. Those triangles over there on that board, I have a triangle ABC and a triangle FDE. And I've told you that these are congruent. But the reason I tell you they're congruent is because I can match some things up. Okay? These little marks right here that are on these triangles, let me rewrite this. these little marks on these triangles tell me things, okay? When I have those little hash marks, that's what those are called, hash marks can match up to the other side to tell me which sides are congruent, or which sides are the same. So, in this diagram, AB is the same as FD over here, okay? Because there's 3 hash marks here, there are 3 hash marks there. BC is the same as DE, because there's 2 and 2. And AC is the same as FE, because there is 1 and 1. Then, with angles, the arc marks, that's what,
Mark.
that's what determines if those angles are congruent, okay? So this angle B is congruent to this angle D because there's only 1 on both of those, okay? Which makes sense because AB is congruent to FD, okay? So that's how I know how to name my triangles. So if I start here on this triangle, it doesn't matter what I start with, and I say ABC, that means over here I have to go in the order that matches. So if I were to say triangle ABC is congruent to triangle EFD, that is wrong, okay? Because A does not correspond to E, okay? So it has to be written in the correct order or it's wrong. You just told me something completely different. Does that make sense? Okay, so make sure order matters when you're doing this. Order matters in everything that we do in geometry with this type of stuff, okay? So those 2 triangles are congruent because you can read it that way, okay? We're going to learn to read things with symbols. Now, triangle X, Y, and Z right here, okay? This triangle is not congruent to either of these, but I know that for a reason. Because if I go to solve what this length is here, okay, if I use like the distance formula to figure out what these side lengths are, they're not going to match the side lengths of that triangle. So what happens is this side length is 1, 2, 3, 4, 5, okay? And I know that this is 5 as well, this hypotenuse, because I know this is a 3, 4, 5 triangle. So I know that those are 5, but here's the deal. If I figure out what this length is and that length is, and one of the 3 don't match, then they're not congruent triangles. Does that make sense? It's all or nothing, okay? We're all in or none of it is working. So that's what we need to look at there. Now, back to those 2 triangles because we're going to take a look at the picture. Those 2 triangles again, the ABC and DE or FDE, okay? These 2 are congruent, but let's pretend that triangle FDE was drawn up there first, okay? Can you tell me what type of transformation would happen to get this triangle over there? What? Gotta guess. What, Caitlin?
Rotation.
Rotation, okay. Just rotation? What?
Reflection and rotation.
Reflection and rotation. Here's why I know that. Do you see how this spot B and this spot D are both 1 unit away from the same thing? Okay? So that means that at some point I reflected that triangle. Okay? Because they are equal distant from the same point. Okay? So what happens is this triangle actually got translated first and then it got reflected over is what happened. That's how it flips like this, down like that. So there was a translation, there was a rotation and then there was a reflection. Okay, those are the 2 things that took place. Turn to page 53 in your book. Page 53, we're going to talk through 3 problems, 1, 2, and 3 real quick, okay? On number 1, it shows 2 triangles. It says the triangles shown below are congruent. Which pair of angles are congruent? So, who can tell me what angle is congruent to angle A in that picture?
D.
What do we think it is? D? D. Yes, it is D. What angle is congruent to C?
F.
F, okay? So you see how you're reading that? Those Those are types of things. Who has questions on that? Anyone? Okay. Look at number 2. It says select all the congruent pairs of sides. Is segment AB congruent to segment BC?
Wait, say that again.
Is segment AB congruent to segment BC?
Yes.
Yes. Do they both have one hash mark?
Yes.
Yes. If you have a triangle that has 2 congruent sides, what type of triangle is it? Isosceles.
I saw this.
Okay, so congruency can happen within its own self as well. Does that make sense? Okay, is side AB congruent with side AC? Or AB congruent with BC, sorry.
No, A, B, and AC.
AB and AC aren't. AB and EF, are they?
A,
Yep.
B, E,
Yes.
C.
Wow, okay, thanks. AB and ED?
A, B, D,
No.
E.
No.
No.
AC and ED?
Yes.
C,
Yes.
Yes.
ED and EF?
No.
ED and EF? No.
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 Going too fast, I can't.
ED and EF or no? Okay, flip it one more page. Look at number 3. Now you're working with a trapezoid, a polygon, okay? It says the 2 polygons below are congruent. Which answer choice correctly names each polygon so that the congruent sides are in the correct sequencing? Okay, so polygon ABCD is congruent to EFGH. Is that the correct sequencing?
No,
Why not?
because it should be A, B, C, D, E, G, F, H.
Okay, it should be. And here's another reason why not. Because on EFGH and on EFHG, E goes to F. Do those connect at all?
No,
No, so I can't even name it that way. Okay?
completely wrong.